Hey, Algebra 2, we're going to continue with these quadratics and trying to graph them now. You know how to solve all those things. We know how to translate them, but here's the problem. Sometimes our equations look like this, and I don't know much about this one. The only thing I can tell you is that if I plug in 0, I'm going to get -2, which means this point right here should definitely be on my graph. When it's in the standard form, that's the only thing I can locate on the graph. Things that I also know is that it should open up, and this one's going to be a vertical stretch. But as far as exactly finding this vertex, right, or vertex point, we don't really know how to do that. Okay, so here's what we're going to do with this today. You can put it in your graphing calculator. You can try and find out where it is, that sort of stuff. But there's got to be a way to find out this vertex from this equation. And you guys actually already know it because we've already talked about the quadratic formula. It starts with -b, and it ends with 2a. And that's going to give you x, right, or the h value of your vertex, right? So in Algebra 1, we call it x. Now we'll start to call it h because it is a special point. So here's what we're going to do. -b is -8. It's over 2 times 2. So -8 over 4 is -2. We'll take a look at that right there. Okay, so x or h is -2. How do you think we're going to get -10? We're going to plug it in. All right. You guys know. Talk about plugging things in all the time. You get one of those fancy air fresheners, you just plug it right in. Same thing here. If you take this -2, plug it in. Where else can I write here? 2 times -2 squared plus 8 times -2 minus 2. All right, that's all of today's lesson, guys. That's how we get that. Other than that, we're going to ask you questions about the axis of symmetry. Well, you already know that. You already found x is -2, so x equals -2 is the axis of symmetry, right? You know that it opens up, so this is a minimum value, and the range y is greater than, we're going to solve for it here, but you see it's -10. All right, let's do all that again without the table in the way. So all they're saying over here, the idea of symmetry, if it has an integer answer on your table on your graphing calculator, it's going to show you that symmetry. So let's do this again, and if I recall, this one is not as nice. So remember, when we're solving, we have some options, but this is really the only option. So -b over 2a. Ooh, look at that. All right, so it's a good thing we stepped into the other one because this one's going to be a mess. So hang on there. Get your calculator if you need it. I'm just kidding. We're not going to use a calculator. Sorry about that. I just got real thirsty. I don't know how to edit that out yet. My kids get older, they're going to show me. All right, so here's what we have so far. This is my h value, -b, so +4, 2 times a, 2a. That's -6. It's going to be -2/3. So here's what I know. X equals -2/3. The vertex starts with -2/3, and we're going to plug that in to find out what happens next. Okay, stay tuned. Here we go. -3, -2/3, I got to square it, -4 times -2/3, and +6. Right, plugged it in. That's all I did. Plugged it in. Hey, Mom brought home a new air freshener. Open it up, plug it in. It'll smell better. I know, just shut up about it and answer the problem, right? Here we go. 2 squared is 4. 3 squared is 9 times -3. Okay, so I'm going to reduce these guys right here. So I got -4/3. I got negative, so make it +8/3 plus 6. All right, now I'm going to let you in on a secret, okay? Whenever I do this, these two terms right here, not two problems, it's only one problem. They should always be half of each other, right? -4/3 and 8/3, that's half of each other. Okay, that's always going to happen when you're solving for the vertex. So don't take me out of context. When you're solving with the vertex, that'll happen. So that means I get 4/3 and it's +6. That seems weird. So I'm going to write 1 1/3 plus 6. So it's 7 1/3 becomes the other part of my vertex. All right, so a lot of fraction review there. The nice thing here is you did end up with a common denominator, so we didn't have to do anything weird. Okay, but remember, what's in that blue box? They're always half of each other. That really helps when you're dealing with fractions as well. All right, what else we have? A is -3, right? We used that in the beginning. So what can you tell me? Is that a max or a min? So keep in mind, I know this is still new. Negative means it's a frowny face. That means it has a top, some circle max. The range y is less than or equal to 7 1/3. All right, so now we have everything we needed from our list. Okay, we can also write it, and that's what we're going to do eventually. All right, graphing the function. Okay, I can graph it. So what do I need to graph it? I need the vertex, right? I definitely need the vertex. So we're going to do this process to get the vertex. After that, I'm going to show you what we're going to do. You hang in there. All right, negative b over 2a. Negative 2 over 2 is negative 1. All right, so here's what I know so far. Trying to decide where to put it. Negative 1. Here's all I know. That's the middle of the parabola. Dun, da, da, da. I also know that it's going to open up because it's got positive 1, but we got to find out where is the bottom of this thing. I don't know. What should I do? Plug it in. All right, so the vertex is definitely negative 1, and we're solving for the other half. So negative 1 squared plus 2 times negative 1 plus 3. Now don't go making that algebra 1 mistake where you turn this into negative 1, right? Because you know negative 1 times negative 1 is positive 1. So put down the calculator, start using the thing you got there. All right, negative 1 plus 3. Look at that. They're half of each other, right? 1 and 2, half of each other. So I get negative 1 plus 3 is 2. 2. Here it is, 2. Negative 1, 2. That's the vertex. All right, after that, I'm going to go a little bit off script here, right? I want to take and use this thing. Well, what good is that? Well, if I put in 0 for the x's, look at that. Boom, gone. Boom, gone. So 0, 3 is going to be on there. And its reflection, right? Because remember this dotted green line, axis of symmetry, that's the middle. All right, let's go ahead and etch a sketch this graph on here now. Woo-wee, look at that thing. All right, and remember a was positive 1, so it did go up 1 and over 1. That would also get us a way to graph that as well. All right, it is positive. It looks like a smiley face. It's super duper. It's awesome. Okay, that our task here was to graph it. Check things off. You know what I mean? Check it off. All right, we want to write it in vertex form. What? They said write it in vertex form. I said, what? All right, negative b over 2a. It's really sad we don't sing the whole thing. Oh my goodness, what did I do that for? I was thinking of getting to the answer. Negative 10 over 4. Let's make it negative 5 over 2. And I know you want to make it 2.5 or 2.5 and just plug it right into your calculator, but don't do it. Fractions are so easy, man. Here we go. Negative 5 halves x squared plus 10 times negative 5 halves plus 7. Why are we doing that? Because I got to find out the vertex. So far it's negative 5 halves, and we want the other half of it. And I want the other half of it. I don't know about you. If you're still watching it, you want it too. Okay, I don't forget about that. Here we go. 5 squared is 25. 2 squared is 4. Times 2. Okay, so that's 25 over 2. All right, got it. Yeah. Put this over 1, multiply. Negative 50 over 2. Are you kidding me? They're half of each other. Negative 25 over 2. Don't forget we had plus 7 on the end of here. All right, this might seem weird. So what is half of 25? Oh, man. Well, half of 20 is 10. Half of 5 is 2.5. Well, how about that? Okay. What else are we going to do? We're going to add these together. And by add, I mean subtract because the signs are different. So we're going to take away 7, so negative 5.5. Negative 5.5. All right, a value is going to stay a. So here we go. Y equals a x minus h, the whole thing squared, plus k. That's an h, not a b. There we go. Y equals a was 2. Where did we get that? Right up here. X minus negative, no thanks, plus 5 halves squared minus 5.5. We have taken the same equation and gone from standard form to vertex form. Why? Because we were supposed to. Why do we want it in this form? Because it's so much easier to graph. Right? Before, we had no idea. I can't look at 2x squared plus 10x plus 7 and be like, yeah, that should definitely have a vertex at negative 2.5 and negative 5.5. No, we can't do that. All right, let's do it again. What's the vertex form of? All right, I don't know. what should I do? Negative b over 2a. All right, so I get negative 4 over negative 2. That's 2. The vertex starts at 2. I got it so far. Okay, the other thing I know is a is negative 1. So here we go. Negative 2 squared plus 4 times 2 minus 5. All right, again, I want to make sure that I'm dealing with all this mess over here just right. So it is 2 squared, which would be 4 times negative 1. So it's negative 4 plus 8 minus 5. Remember that secret? They're half of each other. So it is 4 minus 5. So I get negative 1. I want the vertex form of the equation. Y equals a is negative 1. X minus h, the whole thing squared, plus k. And we are rolling with this thing right here. Okay. That's pretty good. All right. How can we use it? All sorts of different stuff. All right. So I have this problem on here. I'm not going to go over it just for sake of time here because I want you to understand what we did there. But notice the formula is given here. So it would be negative b over 2a. So we can try and find out the different height of the arch, different things that we're doing here. Just change it to vertex form and we can figure it out. This other one, this one's pretty tough. So if you want to spend some time with it, you can. And what say is we're going to put the origin here so we can see that we have a translation to get to the vertex, which would be somewhere around here. Okay, that is going to go 2,130 feet. All right, so that means it's going to be to the right to 2,130 feet. So if I double that, right, I would need 2 of those to find the length of the bridge here. This is the Verrazano-Narrows Bridge. Right, if you want to get to Long Island, then that's how you get there. You got to go with it. Well, there's another way to get there. It's the outer bridge, but this is your most direct route. And if you ever want to run the New York City Marathon, you actually run over this bridge. So totally up to you. Run it, drive it, whatever you want to do. Okay, so we're going to talk about how far apart the towers are. We're going to use this information, how high they are. We can plug it back in and deal with that. I'll show you that in class.